also a chi-squared test, whatever that test that we're going to perform. It is called a test for independence. And it is a chi-squared test. So what is this independence business that we're talking about? Now that we know y equals mx plus b, and that's a line, right? Would you consider y and x to be independent, or y to be dependent on x? If I change the value of x, y is going to change. So clearly, x and y are, or y is dependent on x. That is the, yes?
Is this 12.2?
Yes.
Okay.
That is the continuous case. This is 12.2. In other words, if you draw a line, it is a continuous line, right? On the real number line. It's great and all. But what if someone asked this question? Right? Now, this is a very silly case, but I'm trying to make a point here. So, if someone asks you, well, does shoe size depend on the salad that you eat? May it be Caesar, we could have a bunch of cases, you know, Italian and whatnot. So we have a bunch of salad levels and we have a bunch of shoe sizes. And we want to know if shoe size depends on the salad that you eat. Now, this is clearly a very, very silly case because there is no connection whatsoever. But how would we perform a test in a case like that? Because it's not as clear-cut as numbers, like y equals 3x plus 2. It's not as clear as a t-test, where we had a bunch of numbers. Not like a goodness or fit test, where we had a bunch of numbers. Here we have categorical variables. Typically, the variable that we use in the column is what we call a column variable. The variable that we use across the rows is the row variable. We have 3 different shoe sizes, and we have, what salads do you like? I prefer Caesar. What else do we have? Ignore everything else. Italian. So in how many levels did we measure shoe size? We measured in 3 levels. Yes? In how many levels did we measure the type of salad that people eat? 3 levels. Caesar, Italian, and club. Our objective is to answer that question. The y equals 3x plus 2, if you remember 2023, this is a regression problem. Do we remember linear regression? Line of best fit. That is pure math. Well, this is based on math too, but we have to do it in a different way. In statistics, if we want to establish a connection between y and x, we collect the data and we perform a test. So, we are going to collect observations, even in this case, and determine if there is a connection between shoe size and the salad that you eat. So, 6 or below shoe size. Who's got 6 or below? One person. What is your favorite salad?
I don't.
You don't eat salads? Me neither. I mean, occasionally I go for Caesar. Okay, that doesn't help. But I'll still put 1. And the rest 0. Medium. Shoe size between 6 and say 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Who prefers Caesar? 1, 2, 3, 4, 5. Italian. 1, 2. Cobb. 1. Okay. Large. 1, 2, 3. Caesar. 2. Italian.
Oh, you didn't count me for that, did you? I was just not putting my hand down.
So, Caesar or no?
No,
No.
not
Italian?
Yep.
Cool. Okay. You see what I just did? I collected observations and just filled it in. Just by looking at this, how would we determine, do you think that there is a connection between, you know, the shoe size of the person and the type of salad that they would prefer? Absolutely not. As I move from one level to another, there is no change. Yes. Same here. From 5 to 2, there is a jump. The purpose of this test is, if I see such differences, does it mean it is statistically different? In other words, that shoe size determines the salad or depends on the type of salad that you eat. So there are assumptions for this test also, which I want you to look in the textbook. The simplest one or the most important one is each of these counts have to be bigger than 5. So that is one of the requirements. This is another case. I'll just make this up. Okay, so the Y variable, type of beverage, gender, or sex. So the type of beverage that a person would choose would depend on the sex of the individual. Male, female, we have 74, 51. You look at this table, and do you think that perhaps there is a relationship between the type of beverage a person would choose and their sex? Could that be a possibility? Because things seem to vary between sex. So as I go from male to female, there is a jump in how they like coffee and how they like tea. Does that imply that there is a connection? How could you be so sure? What if there is? And that is the purpose of this test. Right? If there is a difference, we want to quantify if it is a significant difference or not. This could just happen because of error.
So does this basically just test like correlation versus causation?
Just correlation.
Okay.
That was my next point. I'm glad you brought that up. So, this right here, this table that we have, is what we call a contingency table. Regression, well, we try to fit a line. That is for continuous data. Contingency table is for qualitative data. But what is the purpose? Regardless of the case, both of them try to determine the correlation between two variables. In the continuous case, if I could fit a line of this sort, clearly y is dependent on x. As x changes, y is going to change. When we have categorical data, we have to construct a table of this sort, which is called a contingency table, and we will use that to determine if there is a correlation between variables or not. Sloan mentioned, oh, is this the test that determines if there is a difference between correlation and causation? No. This test and regression, they all establish correlation, but keep in mind, no matter the case, correlation does not imply causation. It doesn't matter whether it's continuous, discrete, qualitative, mixed, doesn't matter. If we find correlation between two things, we cannot say that one is the result of another. It's not a cause and effect relationship. Keep that in mind. Common mistake. In other words, if we did establish a connection between the type of beverage and the sex of an individual, we can't say that the type of beverage is always due to the sex of the individual. Right? If I assert it, then, it's a cause and effect case, but that's not what we're talking about. We're saying, is there a connection? Yes, there is a correlation. Does that make sense? So, when I want you to think about examples with contingency tables,